Good morning, all of you, and here is an interesting question in the same style of G. And here we go. We have to find all this as a function of x. So function of x minus mx. F of 0 is quite easy to find because 0 is 0 minus 0. So f of 0 is 0. Now to analyze the capital function f of x, 0 by 0, we'll get 0 by 0. So that is indeterminate, in fact not defined. So in the lower limit, we have to keep limit x tends to or y tends to 0 plus 0. Tan inverse x over x will go to 1. So the limiting value of this is 1. And when x is infinity, tan inverse x graph, we can see it's statically increasing. It will saturate to pi by 2, minus pi by 2. So when x is infinity, this is going to pi by 2 or minus pi by 2. And this is going to plus minus infinity. So overall, the expression tan inverse x by x will die, right? So this will roughly the picture for tan inverse x over x. Now, this quantity tan inverse x by x is lying between 0 to 1. So clearly from the graph we can see it's lying between 0 to 1, right? So now something between 0 to 1 minus m can give any values because it can be positive, negative and 0 depending upon the value of m. So let's take three cases: when m is less than 0, when m is more than 1, and when m belongs to 0 to 1. Right? Now for m less than 0, we'll have m less than 0 as this line. For any value of m more than 0, and let's say this is a value of m belonging to 0 to 1. So under these three conditions, I am going to analyze f dash x. It is more than 1 anyway, so it's always negative. Hence f dash x will be strictly, hence f will be a strictly decreasing function. So f0 is 0 and it's a strictly decreasing. So anyway, we will not have to real root. So this case of m greater than 1 is already gone. Next is what will happen if m is less than 0. So for m less than 0, again if we calculate f dash x, is something between 0 to 1 minus something less than 0. Now negative negative will become positive, so our quantity is positive, hence the function fx will be strictly increasing. So since we know f0 is 0 and if function is strictly increasing, still will have no other root apart from x equals 0. But that we don't want. We want it should have two real roots between minus infinity to 0 and 0 to infinity. Clearly x equal to 0 is the obvious solution, so we are not interested in that. So now I am left with third possibilities when m is dancing from 0 to 1. So when m is dancing from 0 to 1, in that interval you can tell we'll have 2 points of intersection with a given m for the curve tan inverse x by x. So let's call this alpha and beta. So basically now we have three intervals. One interval is from minus infinity to alpha, other is from alpha to beta, and other is from beta to infinity. So we'll analyze these three intervals one by one. So when x value is from minus infinity to alpha, under that condition, m value is more than tan inverse x by x. So m is more than tan inverse x by x for any m belonging to 0 to 1. Hence this quantity f dash x will be negative. Between alpha to beta, since tan inverse x by x is winning, so it will be positive, and more than beta, still it will be negative. So we know f dash x is negative, positive, and again negative depending upon alpha and beta. And this alpha and beta itself will be dictated by what value of m I am taking. Let's say if someone changes the value of m to a new location, we'll have new beta and new alpha. Okay, so I hope this is clear. With this basic analysis, now since we know f0 is going to be 0, and at f beta or f alpha, we'll have point of extremers. So the function must increase from alpha to beta because we have seen in that interval f dash x is positive. Now of course it can't increase like this, right? So it has to pass through origin. So the only possibilities for the curve will be at alpha it has slope 0, again at beta it has slope 0, and the function is strictly increasing. Now after beta, function should decrease. So now it can decrease in two ways. Either it will decrease like this or maybe it will decrease like this, right? Similarly, from minus infinity to alpha, either it can decrease like this or maybe it will decrease like this. So now we have to check like which of the possibilities is true. Can the graph behave this way or it has to behave that way? Okay, so out of these possible ways, the graph cannot clearly behave in a saturation mode. The reason is very obvious. If I'll check the value of f dash x at x tending to infinity, so this, since this quantity is going to 0 and m is a positive value, like from 0 to 1, so clearly f dash infinity is going to be something negative, right? Negative finite, so it may be minus half, minus 1 by 3, minus 1 by 20, okay, whatever, even irrational values, whatever it is. So now clearly this graph cannot be true because f dash infinity is showing 0, right? So the graph cannot saturate like this. It has to be strictly monotonically falling down. Okay. Similarly, graph cannot saturate because f dash infinity is going to give some finite value minus m. So in that sense, still graph has to be monotonically decreasing in this interval. So that shows we have two roots. One is maybe x2, which is less than 0, and there is x1, which is more than 0. So that solves the problem. There is one small thing. If you are not satisfied with the last reasoning, then of course you can find the double derivative of the function, right? Because suppose if the graph does like this, okay, if the graph gets saturated, then clearly we have concave down in this region and concave up in this region. It means double derivative is also having two different nature. So to understand the nature of double derivative, what we can do is simply we can differentiate. F dash x is already known, tan inverse x over x minus m. Now if I further differentiate to find the concavity or convexity of the graph, so it will give differentiate tan inverse x, leave x minus leave tan inverse x, differentiate x by x square. Anyway, m differentiation is 0. So that gives me x minus 1 plus x square tan inverse x over x square into 1 plus x square. And now we can clearly see for x greater than 0, since this quantity is always more than x and tan inverse x is already positive for x greater than 0, right? So this quantity will be negative because denominator is strictly positive. It means f double dash x is negative for x greater than 0, and what if x is less than 0? If x is less than 0, this quantity is negative, this is strictly positive, so overall numerator will be negative, denominator is positive, so for x less than 0, f double dash will be less than 0. Okay, so what it tells is we have a function f of x, capital F of x, as I have defined. At 0 it dies, and now for x positive, the curve must be negative. F double dash must be negative. It means the rate of change of slope must be negative. So it must be something like this, right? Similarly, for x less than 0, the rate of change of slope should be positive, so curve will be concave up. Okay, this will be the nature. Now it cannot saturate because the moment it will saturate, we'll have some point of inflection over here, about which the concavity of the curve is changing, and that's not allowed. So hence 2 root is guaranteed even from double derivative. I hope you have understood and enjoyed the problem. And more than enjoyment, this is very effective and useful for upcoming JEE. So if you want to solve more problems like this, please do like and subscribe the channel for the quality content. Here is a bonus question for you, and give it a try. Of course, I've given the solutions also, so you can roughly see. F is a continuous function such that it obeys the relationship fx into f of x by 2 equals c power x. Then we need to find them. Now one way to solve this problem is to just do a scam. And since we know like the only function which when multiplied by a similar nature will produce e power x, if f of x has the feeling of e power x in it. So I can start by assuming f of x is probably, let's say, some k e to the power k lambda x. So f of x by 2 is k to the power lambda x by 2. So this is just our guess, because we know of course fx cannot be sine cos, so it has to be e to the power some nature, so that their product will also give e to the power x kind of a species. So if we'll multiply, you'll get e to the power 3 lambda x by 2, and that is e to the power x. Now of course one of the solutions will be when k square is 1 and lambda equals 2 by 3. So I can pick up a solution k equals 1 and lambda equals 2 by 3, and that gives me fx as straightforward e to the power 2 by 3x. Okay, so once we know f of x, rest limit will go to minus infinity. A formal way and a mathematical way, or in fact a legal way of doing this question will be, you can use reoccurrence of this expression. So since fx into f of x by 2 is e to the power x, you keep on replacing x with x by 2, again replace x with x by 2, so x by 2 will become x by 2 square. Again keep on repeating, x by 2 square, x by 2, so 2 cube. Okay, and then multiply all the expressions and directly you'll get GP sum, and that will give you the same answer. So for example, if I decode the first term, it's 1 plus 1 by root k greatest sigma k is running from 2 to n. So basically, let's say if I run k from 2 to 5, this is basically greatest of 1 by root 2 plus greatest of 1 root 3 like this, plus greatest of 1 plus root 5. And as we know, all these values are fractions, so this is going to be 1, 1, 1, all this will be 1, right? So if we have 2 to 5, we have how many times 1? 1 plus 1 plus 1 plus 1, 4 times. It's basically 5 minus 2 plus 1, right? So if you have got 2 to n, it will be n minus 2 plus 1. So the first summation is nothing but n minus 1. Similarly, you can check for the second summation, it will be n minus 1. Third summation will also be n minus 1. And the fourth is sigma k square Westner sum, n into n plus 1 into 2n plus 1 by 6. And if we'll put all these values, that what I have shown over here, these summations are nothing but just trying to fool you, which is a usual trap for JEE, especially mains and advanced kind of examination, so that the problem looks quite beautifully difficult. Okay, and if we'll plug all the values, now it's a simple problem.